Intermediate Algebra for Statistics, using the quadratic formula to solve quadratic equations, Part 3. Lesson objectives: solve quadratic equations by using the quadratic formula. Use the discriminant to determine the number of solutions of a quadratic equation. We'll begin with an example. Example 6. Find the x-intercepts for the parabola f of x equals 6x squared plus 3x minus 2. Solution: to find the x-intercepts, we let f of x be 0 and we solve for x. So now we have a quadratic equation in standard form. A is 6, b is 3, and c is negative 2. Substituting these values into the quadratic formula, we have negative 3 plus or minus the square root of 3 squared minus 4 times 6 times negative 2, all divided by 2 times 6. Evaluating what's under the radical, we get 57. So we have negative 3 plus or minus the square root of 57 divided by 12. 57 is not a perfect square, nor does it have any perfect square factors. So these two numbers are our exact solutions. So the x-intercept is negative 3 minus the square root of 57 divided by 12, comma 0, and negative 3 plus square root of 57 divided by 12, comma 0. Now we can use the 0 feature on the graphing calculator to verify that these are indeed the x-intercepts. So this value is approximately equal to a negative 0.88, and this value is approximately equal to a positive 0.38. Putting the equation in y1, hitting graph, then second trace, then 0, we see the first x-intercept is a negative 0.88 approximately, and then the second x-intercept is a positive 0.38 approximately. So we have verified the x-intercepts. Example 7. Solve 0 equals x squared plus 4x plus 18. Solution: in this case, a is 1, b is 4, c is 18. So using our quadratic formula, 4 will go here and here, 1 will go here and here, and 18 will go here. So this simplifies to negative 4 plus or minus the square root of 16 minus 72, all divided by 2. 16 minus 72 is a negative 56. Because we cannot take the square root of a negative number, we say that there's no real solutions. Let's look at this graphically. So we put our equation in y1, and then we hit graph. We want to know where is this parabola touching the x-axis, because the x-axis is where y is 0, and it's not touching anywhere. Using the table, we see that the smallest y value is 14, and this can be verified by finding the vertex for this parabola. So the minimum value is 14, so there's no real solution. Example 8. Solve 3x squared minus 24x plus 48 equals 0. Solution: a is 3, b is negative 24, and c is 48. Plugging these values in our quadratic formula, we have 24 plus or minus the square root of 576 minus 576 divided by 6. 576 minus 576 is 0. The square root of 0 is 0. So we have 24 plus or minus 0 divided by 6. So this becomes 24 divided by 6, which is 4, and 24 minus 0 is still 24, divided by 6 is 4. So for this case, we have one real solution, 4. So we have seen examples where there's two solutions. The last example, there were no solutions, And this example, there's one solution. And this leads us to what's called the discriminant. Let's verify this graphically. So we put the equation in y1. We hit graph. We see the vertex is touching the x-axis. There's one x-intercept. And from the table, there's one value 0. So when x is 4, y is 0. There is one x-intercept. Lesson objective: determining the number of real number solutions. Process: for the quadratic equation ax squared plus bx plus c equals 0, the discriminant is b squared minus 4ac. This expression is what's in the square root in the quadratic formula. If the discriminant is greater than 0, there will be two real number solutions. Because this is a positive number, you take the square root of a positive number and you get a real number. If b squared minus 4ac equals 0, then the square root of 0 is 0, which is one real number. So we will have one real number solution. And if b squared minus 4ac is less than 0, a negative number, we can't take the square root of a negative number and get a real number. So there are no real number solutions. Let's think about this idea graphically. If there are two real number solutions, there'll be two x-intercepts. And sometimes this is called roots of a function. Just means x-intercepts. When the discriminant is 0, we have one root, one x-intercept. If the discriminant is negative, we are trying to take the square root of a negative number, and there's no real solution, so there'll be no x-intercepts, no roots. Let's do an example. Example 9. Determine the number of solutions of the equation 2x squared minus 3x plus 5 equals 0. Solution. So our first step is to find the discriminant for this equation. So b squared would be negative 3 squared minus 4 times 2 times 5. 3 squared is 9, so 9 minus 40 is a negative 31. Negative 31 is less than 0, so we say there's no real solutions. Example 10. For f of x equals x squared minus 6x plus 12, find the number of points that lie on the graph of f at the indicated height. Number 1, y equals 5. Number 2, y equals 3. And number 3, y equals 1. We'll begin with number 1. X squared minus 6x plus 12 equals 5. We have to put this in standard form, so we have to subtract 5 to both sides. We get x squared minus 6x plus 7 equals 0. A is 1, B is negative 6, and C is 7. Plugging these values in the discriminant, we get negative 6 squared minus 4 times 1 times 7, which gives us a value of 8. 8 is greater than 0, so we have two real solutions. Number 2. X squared minus 6x plus 12 equals 3. Subtract 3 to both sides. We have x squared minus 6x plus 9 equals 0. Substituting the values of a equals 1, b equals negative 6, and c equals 9, we have a discriminant of 0. Therefore, there'll be one real solution, so one point has a height of 3. The last one, number 3, we subtract 1 to both sides. A is 1, b is negative 6, and c is 11. We end up with negative 8, which is less than 0. There are no real solutions. Therefore, this parabola does not cross y equals 1. Let's look at all three. So for number 1, we did 5. There were 2 points of intersection. When y was equal to 3, there were 1. And when y was equal to 1, there were no points of intersection. Thanks for watching.